welcome to True Projects. In this video, we are going to explain about the project, which is PPQC, a blockchain-based privacy-preserving quality control mechanism in crowd sensing applications. Introduction of the project. The project focuses on the use of mobile devices in crowd sensing applications, where users report data to centralized servers for various purposes such as providing weather conditions and road traffic information. Traditional crowd sensing relies on centralized servers and they raise concerns about privacy and security, as the servers may have access to users' private information and sensing data which can be misused. The lack of suitable techniques to detect false information reported by mobile sensing users further compromises the security of the system. To address these issues, the project proposes the use of blockchain-based privacy-preserving quality control mechanism. Blockchain is a technology that enables the secure and decentralized storage and management of digital transactions or records. It is a distributed ledger system where multiple participants maintain a synchronized copy of the entire blockchain network. Each transaction or record, known as a block, it is cryptographically linked to the previous block, forming a chain of blocks. There are many types of blockchain such as Ethereum, Bitcoin, Stellar, Ripple, etc. Each has its unique features, governance models, and target use cases. We are using Ethereum in this project. Ethereum goes beyond just recording transactions. It allows developers to create small computer programs that are called smart contracts. These smart contracts, without the need for a centralized authority, a legal framework, manages tasks like storing and getting evidence data. Ethereum's strengths include its ability to create various decentralized applications which are dApps and its active community of developers. Objective of the project. The project aims to address the issues of privacy and security in mobile crowd sensing, where mobile users report data to third-party servers for reward. Blockchain is employed as the foundation for storing and managing mobile sensing users' data. Instead of sending data to a central server, mobile users interact with the smart contracts on the blockchain to store and access their data. Homomorphic encryption safeguards the confidentiality of mobile users' data by enabling computations on encrypted information, preventing exposure of sensitive details during the verification and processing. It allows for secure and privacy-preserving verification of data to detect false information submissions by mobile users, enhancing the integrity and trustworthiness of the crowd sensing system. To implement this project, we need hardware and software requirements. Coming to hardware requirements, we need processor of i5 and above, RAM of 8 GB and above, and ROM of 25 GB and above. Coming to software requirements, we need Node.js, Python of 3.7.0 version, and Visual Studio Community version. To implement this project, we have designed various modules in the methodology. The first one is Generate a Mobile Crowdsourcing Network. This module generates random mobile sensing users who report data to the publisher. Submit data. This module allows the selection of a desired mobile user to report data to the server. The server then verifies the user's data by calculating the noise value. If the noise value is small, then user is rewarded. Otherwise, the rewards are reduced. Algorithm running time. This module plots the running time of all different algorithms. Blockchain integration. The project suggests substituting third-party servers with blockchain distributed servers to guarantee data integrity and access control for authorized users, thereby enhancing security. Smart contracts play a vital role in generating blocks for user sensing data and facilitating data retrieval, guaranteeing both transparency and unalterability of the stored information. The project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is crowd sensing file. This file consists of a Solidity code. It handles data structures, functions and events with modifiers for validation. Now we have to open HelloEth folder. This is the node module folder. It contains dependencies or modules needed for our project. So now we have to open it. This is the bin folder. This folder contains executable scripts related to the project dependencies. Now we have to open it. This is the run blockchain.bat file, which is a Windows batch script to start the blockchain. This script will initiate the local Ethereum blockchain for development purpose. Now we have to double click on it to start the blockchain. Blockchain is hosted on the local machine at the address, which is the localhost, and the port This address allows us to interact with the blockchain using various tools and applications. So here we need to execute the command, which is truffle space migrate. And now we need to click on enter. This will compile and deploy smart contracts. Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. After running the migration, we will receive a unique contract address. This is the unique contract address. This address represents the location of our deployed smart contract on the blockchain. And here we have gas used. To execute the Solidity file and compile smart contracts, this is the amount of gas used. Now we have to minimize it and get back to the main directory. This is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file to execute the project. Now we need to double click on it to execute the project. The graphical user interface of the project. With this we can interact with the program, and this is created by using the Tkinter library. So first we need to click on generate mobile crowdsourcing network button to generate mobile sensing users. So I am clicking on this button. Here red color circles represents participants, which means mobile sensing users, and the blue color represents the publisher. Now we need to select mobile sensing user from the drop down. So I'll select 4 as the mobile sensing user, and now I need to click on submit. So here we can see that P4, which is participant 4, is submitting its location data to the publisher. And in the text area, we can see which participant is submitting the data and its secret key, and we can see original location data, which are latitude and longitude. And here we can see privacy applied on location data to get length integer values. And here we can see ground truth and received values. Here which has some noise. Based on noise, reward is calculated as 1. And these values will get increased as long as user report truthful data. Now we will select some other mobile sensing networks which are users and then submit data. So I'm selecting 8 as the mobile sensing user, and now I need to click on submit. Here we can see that participant 8 is submitting its location data to publisher. Now we need to click on algorithm running time. So I'm clicking on this button. This is the algorithm running time graph. Here on the x-axis it represents number of participants, and on y-axis it represents running time. Green color represents proposed PPQC and blue color represents existing PPDA. From the graph we can understand that proposed PPQC is performing well. Now we will close the graph, close the GUI. Conclusion of the project. The project's adoption of blockchain technology significantly enhances security and privacy, ensuring data integrity and protecting sensitive user information through techniques like homomorphic encryption. By replacing centralized third-party servers with blockchain-based distributed servers and utilizing smart contracts, the project achieves decentralization and transparency in data management, enhancing trust. The implementation of noise value verification and rewards management on the blockchain improves the reliability of data submitted by mobile sensing users, while also detecting and addressing false information submissions. The project's reward system incentivizes users to provide accurate data, fostering fairness and trust within the crowd sensing ecosystem, ultimately enhancing the quality of the data collected.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.